Prime factorization. Prime factorization. In order to complete a prime factorization question, we must understand some vocabulary. Factor, a number that divides evenly into another. Prime number, a number that has exactly two factors, itself and 1. So what that means is the only numbers that can divide evenly into that number is itself and 1. Composite numbers, any number with more than two factors. So more numbers that can divide into that number evenly is more than itself and more than 1. So it could be 2, 3, 7, 12, more numbers. Prime factorization is the expression of a number as a product of prime factors. Okay, product is the answer to a multiplication problem. So we're going to be writing an expression as multiplication, no answer, just the expression part, prime factors. So we're going to write the numbers being multiplied that will be divided evenly, but only the prime ones. So let's look at some most commonly used prime numbers. So for 1, the factors are 1 times 1. Well, that is not 1 in itself because 1 is itself. So that's not prime or composite. So let's move on. 2 times 1. All right, because those are the only two numbers I can multiply to make 2. 2 is prime. 3 times 1 is the only way to make 3, so 3 is prime. 4 can be made by 4 times 1 or 2 times 2, so that's composite. For 5, we can only do 5 times 1, so it's prime. For 6, we could do 6 times 1 or 3 times 2, so that's going to be composite. For 7, we can only do 7 times 1, so it's prime. For 8, we can do 8 times 1 or 4 times 2, so it's composite. For 9, we can do 9 times 1 or 3 times 3, so it's composite. For 10, we can do 10 times 1 or 5 times 2, so that is composite. So these are some of our commonly prime numbers that are used. The next two on the list that are also used are 11 and 13. So let's get started on a question. What is the prime factorization of 600? And we're going to be using what we call the tree method. So what we're trying to do is figure out what we can multiply to make 600, and we only want to use prime numbers. But that's really kind of hard to start with, so we're going to think about just two numbers that we can multiply to make 600. And we know that 6 times 100 is 600. But these are not prime numbers, so I have to keep breaking them down until I only have prime numbers that I'm multiplying. So let's try 6. We can do 3 times 2. There's some prime numbers, so let's circle them. Okay, for 100, I could do 4 times 25. No prime numbers, so I'm going to have to break it down even more. So 4, I can make 2 times 2. There's some more prime numbers, so I'll circle them. For 25, I can only multiply 5 times 5 to make 25, and 5 is prime, so I circle them. Then what I'm going to do is take all the numbers that I circled, and I'm going to write them as an expression using multiplication symbols. I'm going to line them up from least to greatest. So I have 2 times 2 times 2, because there are 3 2's, 1, 2, 3. And then I have times 3, because there's only 1 3, and then times 5 times 5. So if I was to multiply this all out, it would equal 600. However, we want to keep it as an expression, so we're going to keep it this way, but we're going to take it one more step. We're going to write it with exponents. So the numbers that we see here are going to be the bases. So the first base I have is 2. I have 3 of them, so my exponent is going to be 3. Then I'm going to have times 3. There's no more, so I'm just going to keep it times 3. Then my next base would be 5, so it'll be times 5, but since there's 2 of them, it'll be 2 for the exponent. So it looks something like this. 2 to the third power times 3 times 5 to the second power. Another way to read this is 2 cubed times 3 times 5 squared. And these dots mean multiplication. You could have written it with the multiplication symbol, the X. All right, now let's do this a different way. Let's use something called the ladder method. Remember how I said that you could divide a number evenly and that makes it a factor? Well, let's think about prime factorization as if we're dividing, but let's only divide with those prime numbers. So the first prime number that I can remember that 600 can be divided by is 3, and I get 200, because 600 divided by 3 is 200. I'm going to keep doing this until I can't divide any more with any more prime numbers. So let's try this. 200 I can divide by 2, because 2 is prime, and I get 100. I can divide by 2 again, and I get 50. I can divide by 2 again, and I get 25. I can divide by 5, and I get 5. I'm almost done because 5 is a prime number, so I can divide it by 5, and I get 1. Alright, now I can't divide 1 by any other prime number, so I know I am done now. So these numbers on the outside is my prime factorization. And if you can remember from the previous slide, these are the same numbers that I got last time. And that's the way it should be because it's just a different method. So I'm just going to line them up least to greatest with multiplication symbols between them. Remember, I just took all these numbers on the outside and lined them up. And then I would write it with my exponents. 2 cubed times 3 times 5 squared. And I got the same answer that I got last time. Now remember, when you're using the ladder method, there's some reminders that you need to remember. You must divide by a prime number, and you must divide until you reach the number 1. That lets you know that you have divided out all the prime numbers. Now, it does not matter which method you choose, but just choose one that's easier for you to find the prime factorization. My choice or my preference is the ladder method because I think it's easier to divide, and I usually don't make as many mistakes.